Okay, in part 1, we saw the chemical potential of a component in a mixture of ideal gases. Now let's see chemical potential in a mixture of real gases. So these are the equations that we derived for the chemical potential of a component in a mixture of ideal gases. Mu I is equal to mu I0 plus RTLN PI. Mu I is equal to mu I0 Ci plus RTLN Ci. Mu I is equal to mu I0 Xi RTLN Xi. Okay. These three equations were derived based on the assumption that these gases obey the ideal gas equation PV is equal to nRT. But real gases do not obey this equation. If real gases do not obey this equation, we cannot make the assumption that mu I d mu I is equal to RT d ln P. Why was that? Because we made this assumption assuming that for V we have substituted as RT by P dP, and that's how we arrived at these three equations. Okay, now we cannot make this assumption. So in order for using these equations in the case of real gases, we have to make some corrections for the ideal gas equations, which will be helpful to use it for ideal gases. That is, we have to change the ideal gas equations to suit real gases. For that, the scientist Lewis introduced a new term called fugacity. This new term, fugacity, which was introduced to you for your degree classes. Fugacity is a new function which is a sort of a fictitious pressure. Okay, what does that mean? We had substituted for V as RT by P, and in order to make this substitution, we have to substitute P with a fictitious pressure, that is a function which is similar to that of pressure but which is not actually pressure, and it depends on the nature of the gas. If the nature of the gas is real or ideal, it doesn't make a difference, and that is called fugacity. And this fugacity is a new function which is proposed based on the assumption that at very low pressures, that is when P approaches 0, then fugacity and pressure are equal, or F by P is equal to 1. So what is fugacity? Fugacity is a sort of fictitious pressure such that limit P tends to 0, F by P, fugacity by pressure, is equal to 1. Okay, fugacity is equal to pressure at very low pressures, and real gases approach ideal behavior. Okay, so what is fugacity? Fugacity is a function which was derived by the scientist Lewis in order to why did he introduce this function? This function was introduced in order to use the equations that were derived for ideal gases in the case of real gases. So when pressure is higher, that is when pressure is not equal to 0, F by P is now called as gamma, which is the fugacity coefficient. Okay, or from this we can write F is equal to gamma into P. Okay, F by P it becomes 1 when pressure approaches 0, and when pressure is higher, For real gases, F by P is equal to gamma, and it is called fugacity coefficient. So how do we now use the fugacity in the equations for ideal gases? So we have mu I is equal to mu I0 plus RT ln T. In this, we have to substitute P by fugacity in order to use it for real gases. Mu I is equal to mu I0 plus RT ln F. Okay. So from the previous slide, we have F by P is equal to gamma, or F is equal to gamma into P. Substituting, mu I is equal to mu I0 plus RT ln gamma into P. This is now becomes mu I0 plus RT ln gamma plus RT ln P. Okay. Now we can use the equation for real gases in terms of fugacity coefficient. Okay, we don't directly use the fugacity term, we use the fugacity coefficient term. Now compare these two equations. This is for ideal gas and this is for real gas. They differ by a term RT ln gamma. Okay, so when gamma is equal to 1, fugacity coefficient is fugacity coefficient is equal to 1, that means F by P is equal to 1, or fugacity is equal to pressure. When gamma is 1, this term vanishes and the equation becomes equal to that of the ideal gas. Okay, so for ideal gases where there is no interaction between the gases, mu I is mu I0 plus RT ln P. In order to account for the interaction between the gas molecules, we have to introduce the term RT ln gamma fugacity coefficient, where gamma is the fugacity coefficient. Thus, by introducing gamma, we can account for the van der Waals interactions that arise in real gases.